Grüß, willkommen in einem Fragens video. Welcome to yet another exciting video, in this case episode 32 of my equipment series of videos. This video will be covering modern space combat, which includes why combat in space is critical and how such combat could be conducted. I have to admit at this point I never expected that I'd be covering space warfare in my series of videos covering a potential PRC-US conflict. But it's increasingly obvious to me this will be critical, far more critical than I ever imagined, and I'm now convinced if the conflict goes hot, it'll be immediately be followed by a light show, maybe a light show, or at least some activity in space that will be quite unique, as both the PRC and the US attempt to degrade each other's military satellite systems. Just a quick note, unlike most of my equipment series of videos, getting information about specific satellites, military, is extremely difficult. So this is going to be a little bit more general, although I will be covering some specific satellites. In order to understand why war will almost certainly occur in space, or at least military conflict in space, we need to understand what military uses satellites currently provide. The first and most obvious is observation using, guess what, observation satellites. I should point out I'm only looking at military satellites. I'd expect civilian satellites would also be co-opted in any military conflict. But to keep this video simple, I'm going to be sticking only with military satellites. The most common type are Earth imaging satellites that take satellite images, analogous to aerial photography. Some EO satellites may perform remote sensing without forming pictures, such as in GNSS radio occultation. This would allow each side in any conflict to identify the location of all normally visible military assets. Perhaps assets such as submerged submarines and underground facilities would be safe from their prying eyes, but if employed correctly, this would allow each side to see exactly what the other was doing. The US military uses a large constellation of observation satellites for intelligence, that's GOINT, and surveillance, with famous legacy programs like the KH-11 Cannon providing high-resolution imagery, and newer systems like GSSAP monitoring objects in geosynchronous orbit for space situational awareness. These satellites, managed by entities like the National Reconnaissance Office, NRO, and Space Force, gather data for precise targeting and tracking, increasingly integrating with commercial constellation of satellites such as SpaceX's Starshield for enhanced communication. Getting specific information about military satellites is rather difficult for obvious reasons, but we can look at an example where some detailed information is actually available. This is the French CSO military system. The CSO system comprises 3 defence and security satellites. The CSO-3, the third satellite, is shown in this image here. The trio of satellites has 2 distinct missions: reconnaissance for CSO-1 and CSO-3, and identification for CSO-2, affording high resolution and refined analysis. The very high resolution optical instruments flying on each satellite is a marvel of technology built by prime contractor Thales Alenia Space. Now, that was a bit of an advertising spin that stuck into my script. My apologies. Anyway, if we look at CSO-3 satellite, the CSO-3 satellite is a Sun synchronous orbit, SSO, approximately 800 kilometers above Earth, serving as a French military Earth observation asset launched in March 2025. CSO-1 is in a similar orbit, about 830 kilometers, and CSO-2 is in a closer orbit, about 480 kilometers. CSO-1 and 3 are reconnaissance satellites, while CSO-2 is a identification satellite, which I assume is why it's in a closer orbit. If we look at a US system, the KH-11 Kennard satellite system is, I must admit, rather old, but it is still operational and highly effective to this day. The KH-11 Kennard satellites orbit Earth in specific classified orbital planes, often repeating every 4 days, to provide near real-time imagery with ground stations for data reception and data relayed via satellite data systems, SDS relay satellites. The ground stations which it uses are historically at places like Fort Belvedere, Buckley Air Force Base, Kaputen Air Station in Germany. The satellites themselves are constantly moving in low Earth orbit, with multiple units flying in constellations to provide global coverage, making their location a dynamic orbit rather than a fixed point. In December 2018, there were 320 known military or dual-use satellites in the sky, or space, half of which are owned by the US, followed by Russia, PRC and India. Today, the US operates about 250 military satellites and the PRC about 150 military satellites. These do not include dual-use satellites. Many are communication satellites, military communication. Typically, military satellites operate in the UHF, SHF, also known as X-band, or EHF, also known as Ka-band, frequency bands. These allow military assets to communicate with each other irrespective of their location. In a simple application, this allows forward observers in mobile bases in, let's say, in the Philippines, to call down SSM, or surface-to-surface missiles, or air support against any enemies that they sight, if required. If the war becomes hot, or if a war becomes hot, the US could link in forward ROC, or Taiwanese observation posts, involved in fighting against PRC invasion forces, and this could allow them to rain down SSMs on the invasion forces, which would have been launched 1,000 kilometres away, nice and safe. If this was the case, the PRC would be forced into attempting to degrade the US communication capability. Otherwise, they would be unable to resupply any forces in Taiwan if the ROC observation capacity was available to observe supply vessels. I mean, obviously, this would only occur if the ROC observation capacity was able to observe supply vessels. That means the PRC was unable to get really deep into Taiwan before the US got involved, which is not impossible. The next type of satellites are the navigation satellites, which provide GPS capability to military assets and weapon systems. In 1978, the first experimental Block 1 GPS satellite was launched, and by December 1993, GPS achieved initial operational capability, IOC is what the US calls that, indicating a full constellation, that's 24 satellites, that were available and providing the standard positioning service to their ground-based forces. Full operational capacity was declared by Air Force Space Command in April 1995, signifying full availability of the Military Secure Precise Positioning Service, or PPS, which cruise missiles, aircraft and other assets, military assets, utilise a great deal. A GPS network allows the launching of a long-range cruise missile against static targets with a high level of precision. If a high-value target was present in a port, such as ships unloading supplies or troops, the opponent could launch a cruise missile salvo against it, only requiring its GPS coordinates. There would be no need for in-flight repositioning or guidance or anything. Once again, if the war goes hot and the US starts using long-range cruise missiles, or vice versa, it would be critical for the PRC or US to degrade the opponent GPS network. Another class of satellites are early warning satellites. These are likely not going to be a primary target, but will be critical in ensuring a very unlikely ICBM launch does not occur against each side, or at least it will identify it if it should occur. I suspect these satellites will be left alone. I mean, I really do suspect that, unless maybe they're dual-use satellites, which would be highly unlikely. The US has stated any attack against its early warning system will get a nuclear response, and I suspect other nations will have a similar position. At all costs, a nation will avoid affecting these types of satellites, as that could be construed as a prelude to a nuclear strike. Early warning satellites are typically in geostationary or Molnier orbits. A Molnier orbit is a highly elliptical orbit with an inclination of 63.4 degrees and an argument of perigee of 270 degrees and an orbital period of approximately half a sidereal day. The Molnier orbit has a long dwell time over the hemisphere of interest while moving very quickly over the other. It typically approaches to within 600 kilometres of Earth. A geostationary orbit is typically about 36,000 kilometres from Earth. The orbits of early warming satellites is an important fact to consider, as it does significantly restrict the use of kinetic ASAT weapon systems to low Earth orbit satellites, if at all. Any significant debris in an orbit which contains an early warning satellite would be a significant red flag to an enemy. Even if this was not the case and the enemy didn't care, it would affect all nations with early warning satellites, which included the nation which launched the ASAT weapon system. While nuclear weapons have definitely dramatically reduced the possibility of another world war, this is dependent on the MAD concept, mutually assured destruction, which does require early warning systems. Finally, we have satellites which provide in-flight navigation to long-range weapon systems. An SSM, or surface-to-surface missile, launched 500 kilometres or 1,000 kilometres from a moving target will need in-flight navigation changes. Unless there was an observation platform close to the target guiding in the SSM. Assuming this forward observer did not exist, which is highly likely if targeting an enemy fleet, a satellite could identify a naval target from space, and using this information, a salvo of SSMs, or surface-to-surface missiles, could be launched from a significant safe distance away. If the target was moving, the satellite would need to provide updates to the SSMs, or surface-to-surface missiles, allowing them to come within local acquisition range for their final flight path. For example, the YJ-18, which is a PRC Navy SSM, has the ability of allowing mid-course updates through data links, while in most cases the data links will be to the launch platform, which in turn may be connected to an AWACS aircraft or other aircraft. It could also be connected to a satellite, which is monitoring the movement of the target. In most cases, any satellite would need to be in low Earth orbit in order to provide high-resolution detail, ranging from an orbit of between 400 to 200 kilometres. No nation could operate naval assets if such a weapon system was being used against them. They would need to destroy the enemy's ability to acquire targets and guide in missiles, otherwise they would be unable to sail anywhere. If it should occur, and we do end up with the situation, it's going to be a massive frenzy of missile fire in all directions, with possibly the winner being the nation which had the largest stockpile of missiles and the largest number of naval vessels, something either side would be eager to avoid. I personally suspect, and this is my personal opinion, more than any other reason, this is why a blockade strategy by the PRC against Taiwan would fail. If the PRC attempted to blockade Taiwan, the US would simply sail in, daring the PRC Navy to attack it. The PRC would understand once the war became hot, the US would immediately degrade the PRC's space capability and use its own currently much larger space-based capacity to launch salvos of SSMs at any PRC naval asset which was a threat at a very safe distance. The PRC would need to quickly withdraw its vulnerable naval assets, and the blockade would fail before it even had any impact, assuming it resulted, obviously, in a conflict with the US, that is, a hot conflict, military conflict. If the PRC avoided attacking US ships, then this scenario would be avoided. If this was the case, the blockade would only have a minimal economic impact on Taiwan, as well as having probably a much larger impact on the PRC. As a result, I'm uncertain of the point. I mean, there are scenarios where this would be a valid scenario. Let's say the ROC deciding to declare a total independence, then the PRC may threaten this sort of action. But that's That's not going to end up in a major war, in my opinion anyway. Any future war, if it should occur, and I certainly hope it doesn't, would likely involve an amphibious landing, and all effort would be made to avoid attacking US vessels. This is probably going to result in a Ukraine-like war, with the West supplying Taiwan with whatever it needs, and the PRC are desperately attempting to take Taipei before the Western-supplied SSMs destroy their navy and supply capacity and their economy gets damaged too much. The PRC could win such a war, I'm not saying they couldn't, but it would take many years at a truly horrific economic cost. So in conclusion, after analysing this quite a bit, if the PRC and US actually engaged in a hot military engagement, there would be a lot of action in space. It's likely most of the critical action, which would decide the entire war, would actually occur in space and would be over comparatively quickly. This could be an example of a war being decided in space. Okay, now let's look at the space weapons designed to degrade or destroy satellites. These are generally classed into two buckets, kinetic or non-kinetic. There are some crossover ones such as chemical sprayers, but generally kinetic, non-kinetic. Kinetic weapons are the most mature and are currently fully operational, and we know they would work extremely effectively. As a result, the most likely weapon system which could be used are kinetic AST weapon systems, at least in theory. ASAT weapons appear to be the most straightforward and effective way of destroying satellites. With flight times of less than 10 minutes to reach low Earth orbit satellites, they leave their target little time to detect and react to an attack. Yet their use does entail a number of important drawbacks. The primary one is the debris cloud created by a violent kinetic impact with the targeted satellites and the serious danger such debris causes for other satellites, including one's own satellites at the same and in adjacent orbits. Moreover, DA ASAT weapons are like large fireworks, that's a kinetic anti-satellite weapon, giving away instantly their launch point on Earth and thus the identity of the attacker. Therefore, their use would most likely trigger a response in kind. Well, obviously. Considering the vulnerability of one's own satellites to anti-satellite activity, this is hardly a comforting and desirable solution for potential aggressors. To complicate things, the United States has already threatened to respond with nuclear weapons if elements of its NC3, that's its communication satellite network, come under attack with non-nuclear weapons. I would also strongly suggest that any of their early warning satellites would also be a red flag and trigger. Other nuclear-armed states should be expected to react similarly. The stakes are therefore very high. All these considerations transfer kinetic ASAT weapons into a not for first time use but rather for retaliation to deter possible enemy kinetic ASAT attacks. I'm uncertain the US would respond with nuclear weapons, but it does show how risky a hot war will become, particularly if it's space-based. If the alternative, on the other hand, you need to also consider if the alternative is the loss of thousands of US lives under a hail of PRC Navy SSMs, I suspect the US would consider destroying the enemy's ability to conduct such long-range attacks by destroying its at least low Earth satellites. If the US conducts this kind of operation, the PRC will automatically follow. However, before this occurs, all possible non-kinetic weapons would almost certainly be used first. The question is who would benefit the most from a mutual destruction of satellites, and my gut feeling is probably the PRC. As a result, the problem of debris and the ease of attribution that would normally dissuade states from using kinetic ASAT weapons could be partially offset by resorting to non-kinetic options, which seems to be a major focus these days. The first among these options is electronic attack. used to overwhelm satellites' uplink or downlinks with random radio frequency noise jamming, or by corrupting the contents of those links through what is called spoofing. Electronic warfare techniques developed over the decades for use in ground, naval and air combat could be readily employed to impair satellites or even seize control of them. Following the lead of the United States and Russia, several states possess such anti-satellite electronic attack capability. It's extremely likely the PRC also possesses such systems, and if it hasn't yet surpassed Russia, I suspect it will soon, but I personally feel it's definitely surpassed Russia in these areas. Another non-kinetic option is resorting to direct energy weapons, primarily laser beams that could dazzle or harm sensitive electro-optical sensors carried by satellites, as well as streams of high-powered microwave HPMs to interrupt or even perhaps damage on-board electronics, EMP basically. On the plus side, electronic attacks and directed energy options both eliminate the debris problem, complicating the task of identifying intruders, which, if there's a war between PRC and US, that's not going to be an issue, and deliver attacks far faster, obviously at the speed of light, and generally increasing the number of shots an aggressor may take. Thus, in some ways, it could be more effective. On the downside, ascertaining and judging the effectiveness of such attacks beforehand or even during attack is really tricky. Their impact is temporary, generally, meaning that they will be effective as long as an electronic, laser or HPM emitter is turned on and the targeted satellite remains within range and line of sight. This also implies that the longer the duration of the attack and its emission, the higher the chances of detection, countermeasures, counteractions and ultimate retaliation. Well, once again, retaliation is not going to be an issue here because that's going to be assumed. There are also important technical limitations to reckon with. For both electronic attack and directed energy weapons, the intensity of electronic signals and laser beams decrease with the distance from the source, and they are further weakened going through the atmosphere. A straightforward fix is moving the source closer to its target by installing electronic attack or directed energy devices on spacecraft. This attribute of electronic attack and directed energy options increases their attractiveness as the technique of choice for space-to-space engagements. Thus, in summary, anti-satellite, ASAT energy weapons using directed energy like lasers or microwaves to disable or destroy satellites offers non-kinetic ways to disrupt enemy space assets without creating large debris fields, unlike, obviously, traditional kinetic ASATs. These systems, developed by nations such as PRC and US, can dazzle sensors or damage components, operating offensively or defensively although I must admit precise attribution is difficult. This makes them a significant part of modern space warfare, alongside kinetic interceptors that may cause hazardous space junk and would be a last resort. They will almost certainly be the first choice of action, and I suspect this is where the primary development of new anti-satellite weapon systems will occur. However, I'll be honest, I'm unaware of the specific systems that are actually deployed in space at the moment. However, even today, the US and PRC satellites are conducting complex maneuvers around each other as each side attempts to discover more information about each other's satellite capability. Most of these maneuvers are occurring in geostationary orbit. Currently, they take weeks to complete, and at least one major attempt by the US to obtain information from a pair of PRC military satellites were thwarted by a response by one of the two satellites. The US used its USA-270 patrol satellite to attempt this close pass. It appears in this case the PRC was using an escort satellite to protect its more important partner, which is an interesting foretell of what may occur in the future. A Chinese satellite also made a very close approach to a SpaceX Starlink satellite in December 2025, which occurred at a much lower altitude. There may well be some satellites out there with energy weapons. I strongly suspect that there must certainly be, and there's quite a few of them. However, it should be noted that energy weapons do require lots of energy, and many satellites may not possess the energy to power such weapons at distance, particularly if they want to try and destroy the enemy. However, if a satellite moves in close proximity, it could definitely have a potent impact, which is why these rather complex maneuvers are of great interest to many independent analysts. This would probably primarily be occurring in geostationary orbit, and when these sort of close passes and attacks occur, they would actually take weeks to play out. There is another interesting development. The ongoing development of high-energy lasers, HEL, weapon systems is leading to a new suite of potential anti-satellite ASAT weapon systems among both spacefaring and non-spacefaring weapons or nations. Powerful ground-based HEL systems may possibly be used to dazzle or damage sensors or disable entire satellites. Such use offers several advantages over other counter-space capabilities. HEL weapons could be used both in an offensive and a defensive manner and may be difficult to attribute to a specific actor. Although, once again, if it's a US versus PRC action, I think people will know what's happening. However, I'm unaware if any such system is currently operational which can actually affect satellites, but it's certainly something to look out for in the future. One interesting oddball weapon system that I came across was chemical sprayers. Chemical sprayers are an interesting non-kinetic weapon choice, although I suppose in some ways you could say it's kinetic, but it doesn't destroy anything directly or cause debris, so let's put it in the non-kinetic sort of area. I could not find much information about these weapon systems, but covering an enemy satellite with an opaque chemical could actually impact its performance. At the moment, I'm not aware of any chemical which could actually destroy a satellite, but there may well be some chemicals that could degrade satellites. Nonetheless, if this was to be used, it would still require a close pass. So, based on thinking about this quite a bit, and considering the debris issue, I am strongly of the opinion space warfare will be restricted to non-kinetic methods, using energy weapons or low-energy EMP combined with close passes. However, saying all that, once an ASAT missile destroys a satellite, all bets are off, and we may end up with a pretty impressive light show. And so I come to a close of my rather spacey episode 32 of my equipment series of videos, in this case covering space warfare. Alle guten Dingen kommen zu einem Ende.